Alright, Math 3, just doing some more graphing rational equations. So, you need to remember, okay, we're looking for holes, vertical asymptotes, X-Intercepts, horizontal asymptotes, and we're adding the domain here. So we need to know the horizontal asymptotes, vertical asymptotes, any X-Intercepts, any holes, and then also the domain. Okay, so looking at the first one, the top, when there's no x, it's like x to the 0. So think of that as being 0. In the bottom, we have negative 4x to the first, so the top is smaller than the bottom. So, when the top is smaller than the bottom, the x-axis, or y equals 0, is our horizontal asymptote. Okay. Then the top, there's no x, so there's no X-intercept, so nothing's going to cancel out, so there's no holes, so we just need our vertical asymptote. So I take the bottom, set it equal to 0, solve for x, we get x equals a positive 4, so x equals positive 4, we have our vertical asymptote. Okay. Then we sketch our graph by going like this and like this. So our domain, we could go negative infinity to positive 4, then we jump positive 4 to positive infinity, or write all reals except x does not equal 4. Don't know which one's easier, but you could state it both ways. Alright, so there's number 1. Alright, number 2, same idea. So we want the horizontal, the vertical, x-intercept, any holes, and the domain. Alright, so x and x, so they're the same degrees. So we use the leading coefficients. So our horizontal is negative 1 over 4, or 1 over negative 4, same thing. So really close to 0. Okay. Then we take the bottom, negative 4x plus 12 equals 0. To find our vertical asymptote, subtract 12. We get negative 4x equals negative 12. Divide by negative 4. And we get x equals a positive 3. So, a positive 3 x, not y. That's our vertical asymptote. Okay, so nothing eliminated, so we don't have any holes. At the top, we set that equal to 0 for our y, or x-intercept. And we get x equals 4. So, at 4, 0 is our x-intercept right there. So that tells us this is going to go down, hit there, and so this one will come here. So again, domain, you could do all reals, except x does not equal 3. Or you could go negative infinity to 3, jump 3 to infinity. There we go. Alright, now 3 and 4. So again, same degree. So we take the leading coefficient, so negative 1 over 1 would be a negative 1 for our horizontal asymptote. So we've got y equals negative 1. Vertical, now we need to simplify these here. I'd start out by taking a negative, because I don't like a negative as a coefficient. So it would be negative 1 over x squared plus 2x plus 8. Over the bottom, we can pull an x out, and we get x plus 3. Now the top we can simplify. Okay, factors of 8, it would add up to a positive 2. And I made a mistake, because if I pulled out a negative 1, that should have been minus 2x minus 8. Okay, so now factors of negative 8 would be negative 2. would be a negative 4 and a positive 2. So I'd have x plus 2 times x minus 4 times negative 1 over x times x plus 3. So for vertical asymptote, we're going to have two of them now. One at x equals 0 and one at x equals negative 3. Okay, so at 0, 0 and negative 3, 0, we have getting X-intercepts and vertical asymptotes mixed up. So x equals 0 and x equals negative 3. So we have two vertical asymptotes here. Okay. Now we take the tops for the, we just kind of forget about that guy. So we go x plus 2 equals 0 and x minus 4 equals 0. So as we see the pattern here, we should realize we're just taking the opposites. So add 4, we get x equals 4. So my x-intercepts are negative 2, 0 and 4, 0. Okay. So negative 2 x-intercept and positive 4 x-intercept. Okay. Nothing canceled out, so no holes. Okay. And then we sketch our graph. So we're going to start down here, then shoot up. Then remember, and when we have more than one vertical asymptote, it's kind of like we don't pay attention to the middle. Since this went up, we're going to jump down here on the opposite side, go up through, jump again, and then come down this way. So it looks something like that. Okay, so my domain, negative infinity to negative 3, jumps negative 3 to 0, jumps 0 to positive infinity. Or I can just write all reals, except x does not equal negative 3 and 0. Alright, so there's that one. So now we'll take a look at number 4 and do the same process. Okay, so starting off, same, so negative 1 and positive 1. So negative 1 again for our horizontal asymptote. Okay, then we simplify. So I'd pull out a negative 1. So we like negative 1 times x squared plus 3x plus 2. Which that I could simplify further. And that would give me negative 1 times x factors of 2 that add up to 3. Be a positive 2 and a positive 1. Over x squared minus x minus 2. Factors of negative 2 that would add up to negative 1 would be an x minus 2 and an x plus 1. Now, we've got a hole because that x plus 1s are going to eliminate. So I'd go x plus 1 equals 0, giving me negative 1 for the x value. For the y value, I take what's left over, and then I plug in the negative 1 for the x, and simplify. So negative 1 plus 2 is a positive 1 times a negative 1 is a negative 1. Negative 1 over negative 2 is a negative 3, so those cancel. Y is positive 1/3. So at negative 1, positive 1/3, we get that. Alright, so there's our hole. Now, for the remaining, so at that point, negative 1 1/3, so right about there, there's going to be a hole. Okay, then, for the x-intercept, we take the top, x plus 2 equals 0, which we should know just by looking at it. that's going to be negative 2. So negative 2, 0. So at negative 2, we also have an x-intercept. Then for the vertical asymptote, x minus 2, so at x equals positive 2, because we'd add 2 to both sides, we get our vertical asymptote. Then we sketch our graph. It looks something like that. Now for our domain, remember that we can go all reals, but x does not equal. Now that whole plays into factor, so negative 1 or positive 2. Or negative infinity to negative 1 jumps, negative 1 to positive 2 jumps, and positive 2 to infinity. And actually, that's not really correct, because it didn't jump from negative 1 to 2. It would actually jump from negative 1 to negative 1, which I know doesn't make much sense. And then it would go from negative 1. We could probably just keep it out because we're jumping the negative 1. So yeah, that was right. I was good. Alright, anyway, on to the back page. So, same process, we just keep going through the same way. Okay, this one, top is smaller than the bottom, so horizontal asymptote is y equals 0. There's nothing on the top, so no x-intercept. The vertical asymptote, take the bottom. Well, we could factor the bottom, right? And that would be x times x minus 3. So there's going to be 2 of them. One at x equals 0, and one at x equals positive 3. Nothing canceled out, so there's no holes. And this one's going to be a little different because there's no x-intercepts here, even in the middle. So we'll start out like we normally do up here. But then this would come down and then back up because it wouldn't cross the x-axis. So it would actually look more like that. Except for one tiny mistake, which I seem to be forgetting, these little things. Because that went up, it starts down here and would go like that. So just on the opposite side. So because for some reason, I don't know why I forgot that it goes up and starts down at the bottom. Okay. Alright. Number 6. Okay, the top is, we'll do number 6 last because it's going to have a slant asymptote because the bottom's smaller than the top. Okay, 7, 1 and 1. So it's 1 over negative 2, so negative 1/2 for our horizontal asymptote. Okay, then our vertical asymptote, we would take that and set it equal to 0. Solve. And we'd end up with x equals negative 1. So negative 1, there's our vertical asymptote. The top for our x-intercepts. So x minus 4 equals 0 would become x equals 4, right? Positive 4. Or, since it's an x-intercept, it would be 4, 0. So 4, draw that x-intercept, right? Because you add it. There's no holes. So then we draw our graph. I think we forgot to do the domain here, didn't we? So the domain would be, all reals except when x does not equal, 0 and 3. So here our domain would be all reals except x does not equal negative 1. Or negative infinity to negative 1 jumps negative 1 to infinity. Alright, let's take a look at number 8. Then we'll jump back to number 6. So bottom's bigger than the top. So at the x-axis we have our asymptote. Okay, the top, nothing going on with the top. The bottom, however, we can factor that out so there's no x-intercept. So that would factor, so we'd have negative 3 over x squared plus x minus 6. Factors of negative 6, it would add up to a positive 2. Would have to be a 3 and a 2, with 3 being positive, 2 being negative. So vertical asymptotes, we're going to have x equals negative 3, the opposite, and x equals positive 2. So negative 3 and positive 2. Now normally we start in this quadrant kind of area up here, but because of that negative 3, it'll actually flip it, I'm pretty sure. So we'll actually go down here and jump up here, and we don't cross the x-axis because there's no x-intercepts. Turn back around, come back down here like that. Okay, so then our domain, because there's none of the other things, no holes, no x-intercepts, we could say negative infinity to negative 3, jumps negative 3 to positive 2, jumps positive 2 to positive infinity, or all real numbers except negative 3 and 2. Alright. Now let's look at number 6. Okay. So we've got our horizontal asymptote, our vertical asymptote, x-intercepts, holes, domain. Except the horizontal asymptote isn't horizontal, it's actually going to be a slant asymptote because the bottom is smaller than the top. Okay, so what we're going to do is we're going to take that bottom and we're going to divide it using long division into the top. Oops, that's a 2x squared and plus 0. Okay, so now there's 3. So we go right here, and this needs to become this. To do that, a negative 3 to a positive x, we're going to have to times by the opposite reciprocal. So negative 1/3. X squared to x cubed, we're going to times by an x. So then I multiply that by all 3, and we get x cubed, which is what we wanted. Negative 9 times negative 1/3 would be a positive 9/3, which would equal 3. So plus 3x squared. Then a negative 1/3 times a positive 12 would be a negative 4. So minus 4x. Okay. Now what we're going to do is we're going to change the sign and add them, because that's easier to do it that way. So we add those, that becomes 0, which is what we wanted. 2 minus 3x would be negative x squared. Negative 8 plus 4 would be negative 4x. Then we bring down the plus 0. Okay, then we've got the 3 here. So negative 3x become an x squared. Well, I don't have to times by x's. Negative 3, still negative, so what's up by a positive 1/3? So that would give me negative x squared minus 3x plus 4. We change the sign and add them. 0, negative x, and a negative 4. Now this is our remainder, but for us, we don't care. What we care about is this. So our slant asymptote becomes y equals negative 1/3 x plus 1/3. So to draw that, put it with positive 1/3, which is tough to write on this. So, right about there. And then I'm going, my slope is negative 1/3, so I'm going to go down 1 to the right 3. So not right there. Not right there. Down 1 to the right 3. It's not even close. Close enough. And that's line right about there is my slant asymptote. Okay. Alright, so we did all that work just for the horizontal asymptote, which is usually really easy to get, so it's kind of annoying. Alright, so now vertical asymptote. So now I guess I've got to simplify. So here we can pull an x out, and that gives us x squared plus 2x minus 8. Factors of negative 8 that add up to a positive 2. 4 and 2 with 2 being negative. So the top is x times x plus 4 times x minus 2. And the bottom, we can pull out a negative 3. So it would be negative 3 times x squared plus 3x minus 4. Factors of negative 4, that would be a 3, 4, and a negative 1 to make it positive 3. So it would be negative 3 times x plus 4 times x minus 1. Okay, so now that we've factored those down, now I know I'm going to be able to eliminate the x plus 4s. So for vertical, so we're going to be left over x times x minus 2, negative 3 times x minus 1. So take the bottom, negative 3 doesn't matter, so x minus 1. So we get x equals 1 for our vertical asymptote. So x equals positive 1. Draw my vertical asymptote. Okay, then we take the top, and we have x equals 0 for that one, and x minus 2 equals 0. And these are for the X-Intercepts. So at 0, 0, and at 2, 0, I'm going to have my X-Intercepts. So at 0 and 2, 0. Okay. Now we have one hole, right? So that hole is x plus 4 equals 0. So we get an x value of negative 4. That's a point. So then, that x is still there, by the way. So then I'm going to plug that negative 4 into all these x's and simplify. So negative 4 times negative 4 minus 2 over negative 3 times negative 4 minus 1. So the top, negative 4 times negative 6, which is positive 24. The bottom, negative 3 times negative 5, which is a positive 15. 24 over 15 is 8 over 5, which 5 goes into 8 once, and there is going to be 3/5 left over. So 3/5 is like 0.6, so it's like 1.6. Okay, which you could have used a calculator to probably figure that part out. Alright. So a hole at negative 4, 1.6. So negative 4, 1.6 is going to be like right there. Really close to the asymptote. Okay, so then I sketch it. So we start up here, follow that, then go down. Here we kind of follow it like that. Okay, so our domain, negative infinity to negative 4, jump negative 4, and after negative 4, using parentheses means negative 4 isn't included. We go into positive 1, then we jump from positive 1 to positive infinity, or all reals, except x does not equal negative 4 or 1. And there's all our info. And there we go, guys.